Hello viewers, so welcome to today's video session. Today's video session is all about general chemistry. Okay, in previous class what we discussed? In previous class we discussed about various general inorganic chemistry like shapes of d orbitals. Now we will discuss types of d orbitals, right? Types of d orbitals. So generally what happens, we know that the d orbitals we consider as 5 d orbitals in a d subshell, right? So when you talk about d subshell, we know that d subshell contains 5 d orbitals. Okay, the question arises, why 5? Why not 6? I say it must be 6 d orbitals instead of 5. Instead of 5, it must be 6. But actually this is not correct. This is correct. What is the reason behind that? The reason behind that is quantum mechanics. Quantum mechanics. And from quantum mechanics, you know that the 5 d orbitals is named as dxy, dyz, dzx, dx square minus y square, and dz square. 1, 2, 3, 4, 5. 5 d orbitals. 5 d orbitals in a d subshell. Right. The question arises, why 5 d orbitals? Why not 6? The reason is quantum mechanics. Now the question arises, why I am consistently telling 6 d orbitals instead of 5. See this one, d orbital, right? You know that d orbital contains 4 lobes, right? D orbital contains 4 lobes, and you know that suppose this is my 2 axis. Suppose this is my 2 axis, x axis, y axis, and perpendicular to x axis and y axis, this is z axis. This is my z axis. Suppose this is my orbital. I am having orbitals for you. Okay, sorry for that interruption. So this is 2 axis. Suppose this is x axis, this is y axis, and the perpendicular is z axis, right? This is 3 axes perpendicular to each other. So you have to place these 4 lobes, right? You have to place these 4 lobes in 3 axes, such that you have to find out number of possible orientations. What I discussed, number of possible orientations. Okay, so when you talk about number of possible orientations, you have 2 types of orientation. First one is axial orientation, axial, and second one is non-axial orientation. First one is axial orientation and second one is non-axial orientation. If it is towards the axis, then this is axial orientation. If it is not towards the x-axis or y-axis or z-axis, that is 3 total axis, that is non-axial. If it is in between the axis, that is known as non-axial, right? Similarly, so suppose this is 2 axis. If it is in between the axis, then it is another naming. Suppose if it is on the axis, then it is another naming. So accordingly we have 6 possible orientations. So if this is x-axis, y-axis, this is known as dxy. Suppose this is y-axis and suppose this is z-axis, this is known as dxz. Similarly xy, xz and yz. Suppose this is y-axis and suppose this is z-axis, this is known as dyz. Right? First one, if this is x-axis, y-axis, then this is known as dxy, right? If this is x-axis and z-axis, this is known as dz, and if this is y-axis and z-axis, this is known as yz. This is axial orientation, and non-axial stands for like this. If in between this, right? If this is in between x and y, this is known as dx square minus y square. Similarly, if it is in between y-axis and z-axis, this is known as dy square minus z square, right? xy, yz and zx. Suppose if it is in between x-axis and z-axis, this is known as dx square minus z square, right? Now these are three non-axial possible orientation, and these are three axial possible orientations. So the question arises, why I am choosing this is x-axis, y-axis, why I am choosing y-axis, z-axis, the same axis change to x-axis, y-axis, y-axis, z-axis, z-axis, x-axis, because there is no fixed axis in this space. If this is x-axis, this is y-axis, then that means the another is z-axis, because three axes must be perpendicular to each other. Similarly, I will place this in possible orientation, so I got 6 orientations. Now the question arises, we know dxy, we know dyz, and we know dzx, and we know dx square minus y square. Then question arises, then where dz square come? See this one, this is dx square, dy square minus z square, this is dx square minus z square. You can write like this, dz square minus y square, dz square minus x square, right? So combining these two, you get this one, dz square, d2z square, sorry, d2z square minus y square minus x square. In this short form, it is known as dz square, right? The question arises, why you choose these two, dy square minus z square or dz square minus y square and dz square minus x square? Why not this one? Because this is hypothetical concept, that's why we chosen these two. So similarly, out of 6 possible orientations, we got total 5 orientation in our study, which is a hypothetical concept. That's why we chosen these 2 orbitals for our study purpose. Thank you very much.
बढिया पढाउँछु तिम्रो अक्षर पनि बहुत सुन्दर तर